Every draft season, every coach, every general manager is chasing the same dream, finding the player who's about to break out, not the one who's already a star, the one who will become one. And while scouting used to rely on a sharp eye and a good gut, analytics added something new: prediction. Today we're going to look at how data scientists and front offices build models to forecast success. Because while no algorithm can guarantee a champion, it can make the odds a whole lot smarter. Talent identification has always been one of the hardest things in sports. Some players dominate in college or the minors, but fade in the pros. Others look average at first, then explode when the system finally fits their style. The question analytics tries to answer is simple. What separates those two groups? We're not just measuring who plays well now. We're trying to predict who will adapt, grow, and succeed later. And that's where data modeling comes in. In traditional scouting, success lives in the past. You watch what happened, then use intuition to imagine what might happen next. Modeling flips that. It takes historical data, performance stats, age, position, workload, even psychological and biomechanical data, and asks which patterns tend to produce the best long-term results. That's what a predictive model does. It turns thousands of observations into one clear probability. How likely is this player to succeed? You're not guessing, you're forecasting. A good player model starts with inputs, measurable variables about players. That could be physical stats, height, weight, speed, skill metrics, strikeout rate, shooting percentage, experience, games played, age, level, psychological data, grit, consistency, decision time. Then you define the target variable, what you're trying to predict. It could be probability of making the major leagues, future salary value, number of wins contributed, injury risk. Once you've got inputs in a target, you can train a model, maybe a regression, maybe a classification tree, that learns from past players to predict new ones. Think of it as baseball cards meet machine learning. Here's what building a player model actually looks like. First, collect data, past seasons, scouting reports, combine data, biomechanics. Second, clean it. Make sure missing values, outliers, and duplicates don't mislead the model. Third, select features. Choose which variables really matter. Maybe vertical jump predicts success for wide receivers, but not linemen. Fourth, train the model. Feed it data and let it learn patterns. Fifth, validate and test. See how well it predicts unseen players. Sixth, interpret and adjust. Models are tools, not truth. The goal is insight, not automation. This is the same logic data scientists use in business, except instead of customers, we're modeling athletes. Let's take a simple example. Say you have minor league players with stats like batting average, walk rate, strikeout rate, age, and fielding percentage. You define your target variable as, did they make it to the majors within 3 years? Run a logistic regression, a model that predicts binary outcomes, yes or no. And you get coefficients showing which variables actually matter. Maybe walk rate and age are strong predictors. Maybe raw power isn't as predictive as plate discipline. That insight changes how you scout and train. You stop looking for flash and start looking for repeatable skills that correlate with advancement. That's the data version of finding the next Moneyball advantage. Every sport has its own hidden predictors. In baseball, contact rate, OBP, and defensive flexibility. In basketball, usage efficiency and turnover ratio. In football, yards after contact, decision speed. In soccer, expected assists, off-ball movement, and the real magic happens when you combine them. When your model can look at combinations of traits, not just one stat, you start seeing what scouts can't quantify easily: consistency, adaptability, and growth trajectory. It's not who's best today. It's who's improving fastest. Now, let's be clear. Analytics doesn't replace scouts. It empowers them. A model can tell you a player has a 70% chance of making the majors, but it can't see attitude, leadership, or how a player responds to pressure. The best organizations blend both. The art of scouting with the science of modeling. The data narrows the field. The humans make the call. Think of it as a partnership. Intuition guided by evidence. The best teams use models not just to predict who will succeed, but why. They track player development over time, updating probabilities with every new season of data. When the model flags a player as a breakout risk, coaches can adjust training, diet, or playing time to improve outcomes. It's not about predicting the future once, it's about continuously improving it. Prediction turns into intervention, and that's where analytics becomes competitive advantage. So far, we've seen how metrics change the game and how models predict the next stars. In the next episode, we'll zoom out and look at entire teams, how analytics helps build chemistry, balance lineups, and optimize performance. Because the perfect player doesn't win championships, the perfect team does. So, see you next time on Sports Analytics, turning data into competitive edge.